which is V plus delta V, that is V dash, isn't it? And then I will write the same way, delta V is proportional to initial volume, delta V is proportional to change in temperature, delta V proportional to V delta T, delta V is equal to gamma into V delta T. Simple, right? From here, what is gamma? Gamma will be delta V by V delta T. And what is gamma called as? Coefficient of volumetric or cubical, whatever you like, you can choose your name. Volumetric, some books will also write cubical expansion. And if I want to write in terms of V, yes, I can write, because V dash minus V will become equal to gamma into V delta T. So, V dash will become equal to V plus gamma V delta T, and V dash will become equal to, if I take V common, 1 plus gamma delta T, isn't it? So, you got the value of L dash, you got the value of A dash, you got the value of V dash. Nikas, it's a long 2-hour class, okay. If you see your watch 10 times also, time will not start running fast. You have to bear this. Can I start the next topic? Is it clear to you? Is it clear to you what is alpha, beta, gamma is clear to you? Okay. So, by seeing Nikas' face, I am giving a 5-minute break. 5-minute timer, please. And 5-minute break is for the people of offline people to sit and relax. Online people can have some fun. Huh? Slightly walk. Thank you for the idea. I was trying to make it 9 o'clock. See his face started laughing. Simply saying, man. Okay, guys, we are back. Please, you also come back from wherever you went. So, I hope everybody had your cup of coffee or sandwich or bread or banana or whatever you are having. Somebody knock. Ghost. Wait. Okay. Okay. Break is fulfilled now. Okay. Yes, I think Niranjan, who came in the waiting room, please allow him inside. Yes. Everybody please on your cameras. We're once again going to start the class. And now we are going to talk about one important topic which comes in the school examination, and that is relationship between alpha, beta and gamma. We learned now what is the meaning of alpha, what is the meaning of beta, what is the meaning of gamma. Now we are going to learn the relationship between alpha, beta and gamma. Okay, let us try to derive that. So, I'll give time for writing. Please pay attention. Understand the derivation. I will give time for you to write. Please pay attention. Okay. So, if you remember, if we had a cube of length L, L and L, and when you heat this cube from its initial volume V, which was equal to L cube, now it may become a bigger V, isn't it? And which will have length L dash, L dash, L dash, and its volume will become V dash, which will become equal to L dash cube. Do you agree? Initial volume V was L cube and final volume V dash will be L dash cube. Why it happened? Because we heated the cube and it expanded in all the directions. Since it is a isotropic, that is all directions will have the same amount of expansion, it became L cube. Okay. Now what is V dash? V dash is L dash cube. Okay. What is L dash? If you see what we have derived before some time, L dash was L into 1 plus alpha delta t. Do you remember? I will put in this. I get V dash is equal to L plus, sorry, V dash I am writing, no man, L dash cube it will be. So L into, once again, if I erase, everything will erase, I am having that fear. I am writing once again. V dash is equal to this thing whole cube, that is L into 1 plus alpha delta t, the whole cube, isn't it? Yes, for both the terms, obviously. And then it will become equal to L cube into A plus B the whole cube. What is that? A cube plus B cube plus 3A square means 1 square into alpha delta t plus 3AB square, 3 into 1 into alpha square delta t square. Do you agree? I hope everybody agrees to this. Nothing big I have done. Just expanded that L dash cube, right? Nikhil, you are still having your video off. Please on it. Is equal to L cube is basically V into, if you see these terms, you will realize that alpha cube delta t cube, alpha square delta t square. You know what is the value of alpha? Alpha will always be in 0.001, 0.0002 like that. 0.001 if you make cube or 0.001 if you make square, it will become very small. So these terms that I have circled, they are going to be very, very small. So we are going to neglect it. Since it is very small, I am going to neglect it. If I neglected it, now V dash became V into 1 plus 3 into alpha delta T. Do you understand? Up to here it is clear? Also, we know gamma. What was gamma formula? Gamma formula was delta V by V delta T. Do you remember? If I open from here, this bracket, if I open, it will become V dash is equal to V plus 3V alpha delta T, isn't it? If I rearrange terms, it will become V dash minus V is equal to 3V alpha delta T. And what is V minus V dash? V dash minus V? Delta V. So, I get delta V is equal to 3V alpha delta T. And if I put the value of delta V here, what I am going to get gamma as, you see? Gamma will become delta V is 3V alpha delta T divided by V delta T. These two gets cancelled, V and V gets cancelled. You get gamma is equal to 3 times alpha. Always remember that coefficient of cubical expansion is 3 times the coefficient of linear expansion. Same way, if I would have taken initially a single sheet L cross L square and heated, it would have become A which is equal to L dash square, and same derivation steps if we followed, then I would have got the value of beta as 2 alpha. Similarly, beta would become equal to 2 alpha, and since beta is 2 alpha, gamma is 3 alpha, I get the relation between alpha, beta and gamma as alpha by 1 is equal to beta by 2 is equal to gamma by 3. This derivation comes in school examination. And this result is used in competitive examination. Yeah, kind of. Alpha by 1 is equal to beta by 2 is equal to gamma by 3. We will take some questions now. Please copy it up. I will give a numerical to you where you will use this. I am giving 2 minutes of time. Please copy fast. Don't take much time, 2 minutes, fast. If anybody has any doubt, you can ask me. Are you done? Make it fast, please, fast. I'll give another minute. Make it fast. So a part of it we use in the competitive class, isn't it? The Sunday's class we just use the L dash, but it is a big topic. Alpha, beta, gamma is a big topic, which comes in thermal properties of matter. Today my aim is to finish this chapter. If you cooperate only I can finish. What remains now is conduction, convection, radiation, modes of heat transfer. Before that we have one more topic. anomalous expansion of water. Interesting topic. I hope you are done. Varshika done? Still doing? Now only starting. Do by yourself, not a big thing. If you need help, I'll help you, okay? I'm erasing the board now. Abhinand, shall I? You're doing some what? Some drawing? Okay. Okay. Those who have done, it is numerical. Question comes, a glass window has dimensions of 200 centimeter by 300 centimeter at 10 degrees Celsius. By how much will its area increase when the temperature is increased by 20 degrees Celsius? They are given the value of alpha as 9 in 10 power minus 6. See how much small is alpha, can you feel? 0.000009. Isn't it? So, solve this question fast. A 3-minute timer, please. 3-minute timer. Yeah. Start doing it. 2. Give a try. Two and a half minutes. Make it fast. दिवस तो प्रेजेंट है ना? हाँ लिया नहीं। हरविश है, ग्लैडविन आया था, कैलाश नहीं आता है, फीस केवल मैथ के लिए है वो। सुगेंद्रन एब्सेंट, निखिल है, श्रीवेश है, जीविका एब्सेंट। Tell me, Akhilesh.
Is the answer 54 centimeters square, sir?
Answer?
54 centimeters square.
54 centimeters square. Let us check. Anybody else?
5.4, sir.
5.4 centimeters square. Okay, let me check. Others, look.
5.4, sir.
5.4.
Yes, sir.
Oh, you changed your answer from 54 to 5.4.
Now only found the 10 to the power minus 1 remaining, sir.
Okay. Lokita, what is your answer? I hope you are solving.
So 108 into 10 to the power minus 1, sir.
1.8 10 power minus 1.
108, sir, 108.
108 she has got. Okay. Others, any answer? Nobody else? Anybody else with some answer?
Sir,
Tell me, Sai Akhilesh, I am hearing.
alpha is linear expansion coefficient only, no, sir?
Yes, Tambi.
Oh, sorry, sir.
Okay.
10.8, sir.
10.8. So Shweta Shinde is the only one who has told the correct answer. Now only you are getting, no? Okay. 10.8. Okay. I think 10 seconds are remaining. We can lock the answer as 10.8. Let us see whether it is right or not. Shall we? Okay. So I'll just go to the answer directly. And the answer is 10.8 centimeters square. For all those in a hurry who told 5.4, 54, are definitely wrong. See, it's very simple question. Delta A will become equal to A into beta delta T. They have written as alpha A, don't confuse yourself, it is beta. We are learning as beta. And then when you find the value of beta, which is equal to 2 times of alpha, you are going to get the answer as 10.8 centimeters square. If you have solved properly, you would have got the answer as 10.8 centimeter square. Is it clear? Is it clear? Any doubt on this very basic question? So I hope you understand how the questions can come from here. Fine. Another question. What, man? This question, copying like this. You don't write alpha A here. I have not taught alpha A. I have taught like beta. You change this to beta. Since you are copying, I am saying to you, Mr. Avinash. Okay. Can I go to the next page, Avinash? Okay. The next page, next question. Fast. A 3-minute timer again. A 3-minute timer. Interesting question. This question comes in school exams. This question actually I have seen in NEET exam also. The same question I have seen in NEET exam also. With options obviously. A blacksmith fixes iron ring on the rim of the wooden wheel of a horse cart. Diameter of wooden wheel and the iron ring are given at 27 degrees Celsius. To what temperature should the ring be heated so as to fit the rim on the wheel? Obviously, there are single measure. Thickness matters means what? Did we say anywhere thickness matters? Delta L or delta A or delta V, we not took thickness at all. We just took the length, area and volume. Think wisely. Already 1 minute is over. Think how to solve this question. Any answer? Solve it. Nearly there. Okay. Is the question clear to everybody? I hope it is. There is a wooden wheel. Earlier days, nowadays we don't do that. When we used to have this kind of horse cart, the wheels will be of wood. They will put a iron ring over the wood so that it will not have much wear and tear. It will have more life. Imagine something like a cover of the wooden wheel. So the diameter of the wooden wheel is 5.243. The diameter of the iron ring is 5.231. Lesser than that, it means what? It needs to expand a bit to fit into that wood, isn't it? You want to find how much heat is required for that expansion. So first thing is you should find how much expansion is required, isn't it? Area, is it area? 5.243 is area. Okay. Is it having, are we going to see here superficial expansion? No, yeah.
Sir, we can use the formula of circumference to find the length 2 pi r.
Yes, 2 pi r. We have to use circumference to find the length, initial length, and length of wooden wheel is given to you by using diameter. Length of iron rim will be given to you by using the diameter. See, circumference is 2 pi r and 2r is d, so pi d, simple. So pi multiplied by, tell me, any answer?
Sir, is the required temperature 218.12 degrees Celsius, sir?
Let us check, I am going to see it. Okay. So they have given the diameter of iron ring as
Yes,
5.
sir, about 210 degrees Celsius, sir.
Okay, let me check. So here see, you may ask one thing to me. So why they have not found the circumference directly? They have solved by using the length diameter itself, because both side pi will come and pi will cancel each other. What they have solved is actually a wrong way of solving. Are you getting why? Because they have used here instead of length diameter, isn't it? What they should do? They should use here pi into this diameter, and here also pi into diameter. Pi will get cancelled, then it becomes correct. But how they wrote here diameter of iron ring is LT1, then they cannot write. They should write circumference as 2 pi r, that is become equal to pi into d. How can you say like that? You cannot say like that. It is length increasing, isn't it? The whole circle is increasing. It's not like that part increasing. It applies, but I am saying wrong. I am not saying it is wrong. I am saying wrong way of doing. It's correct, man. I am saying that the way of doing is wrong. The answer is not wrong. It's correct. So when you put it here, pi will get cancelled. Then everything remains same. 5.243, 5.231. 1 alpha is given to you. Put the value of temperature change. So initial temperature was 27 degree. When you put it here, you will get the answer as what? 218 degrees Celsius. If you have solved correctly, the answer should have come 218 degrees Celsius. If you have got this answer, be happy. If not got this answer also, be happy. Who has stopped you from being happy? Can I proceed further? Can I further?
Yes, sir.
Okay. So now we spoke about coefficient of expansion for solids, right? We talked about coefficient of expansion for solids. Do you think that liquids will also have some expansion? Linear they will have? How can liquids expand linearly?
Volumetric expansion.
Only volumetric expansion, exactly. Liquids undergo only volumetric expansion. There is no linear expansion, there is no aerial expansion in the case of liquids. Liquids undergo only one kind of expansion, and that expansion is what? Volume expansion. So this topic should come after that basically. So if I talk about the volume expansion, let me talk about the expansion in liquids. There are two types of coefficients. One is called as gamma R, one is called as gamma A. I will talk about these both. What is that? So in the case of solid, I took the solid, then I heated the solid, it expanded, and we saw initial volume as L cube, final volume as L dash cube, and then its expansion is V dash minus V delta V, right? If I give you 1 liter of water or 1 liter of oil, and if I ask you, heat it, how will you heat it? Take the oil and directly start heating. First you will keep the oil in a container, right? Suppose you are keeping some container, like any patram you can imagine. Pour the oil, put on the stove, heat it. Heat will first go to whom? Obviously, container. And then the heat will get transferred to whom? The oil. Don't you think that not only the oil expands, the container also expands because of heat? So whatever you are going to get the expansion is not going to be the real expansion. It is going to be the apparent expansion, because it is the expansion of the liquid as well as the solid in which the liquid was kept. Are you getting my point? When you had 1 kg of copper, I can directly clamp it and heat it. I can understand how much is the change in the length or the area or the volume. But if you have 1 kg of liquid, I cannot directly heat it. I have to first keep the liquid in some container. It can be any container, aluminum container, steel container, copper container, glass container, gold container. Keep wherever you want. Whatever container you are going to keep, that container also will expand, because you know that solids expand on heating, and then only the liquids will expand. Am I right inside that? So that kind of expansion is called as coefficient of what expansion? Apparent expansion. I mean, Obviously, it is cubical. It is called as apparent expansion. Gamma A, we write it. So, what was the gamma formula? Gamma formula generally was gamma is equal to delta V by V delta T. So, here if I write gamma A, it will become equal to delta V by obviously V delta T. But what will be delta V here? Apparent change in volume, not the real change. Apparent change in volume. In solid it is the real change, in liquid it will be apparent. Are you getting what is the meaning of apparent change? Because the change is not only of the liquid, it is of the liquid as well as the solid in which the liquid was kept. I hope my point is clear. And so, what will be the gamma R then? It is called as coefficient of real expansion. Yes, real expansion. So, you can understand that the coefficient of real expansion will always be equal to coefficient of apparent expansion plus coefficient of container's expansion. This formula is there. It will be used in competitive examination more, not in school exam much. Remember that coefficient of real expansion of liquid will be the coefficient of apparent expansion added with the coefficient, obviously volumetric coefficient of expansion of the container. It will be solid. Are you getting my point? If you add both these coefficients, then you get the real expansion of liquid coefficient. I hope you are getting. It will be a higher value. Why? Because what is the meaning of gamma? Amount of heat required to expand unit substance to some unit dimension more than what it was initially, isn't it? So, if you talk about the liquids, first when the heat was supplied, the heat was given to solid and then the heat was given to the liquid, and so it is a bigger value. I hope it is clear. Very basic thing. If you allow me, I will erase the board and then I will talk about this topic, variation of density with temperature. It is an important topic. Shall I?
Just a minute, sir.
Make it fast. So, expansion in liquid is not like expansion in solid. There we had only real expansion. In the liquid we have both real and apparent expansions. Real expansion is the one, apparent expansion is the one where the container as well as the liquid both are expanding, and from apparent you can add the container's expansion and find the real expansion. Can I proceed further? Make it fast please. Shall I? I hope all of you have written. Now, what happened, man? I cannot undo it. Not in this. Okay, fine. If you have, I will share the video with you. That time you can copy if you have not copied anything. Pay attention, please. Now, pay attention, please. I have a question for Niranjan from Narayana School. Yes. Question is, if the temperature of the liquid is increased, whether its density is increasing or decreasing, what do you think, Niranjan?
So it decreases.
Decreases, okay. Shweta Karthikeyan, what do you think?
I think it remains the same, sir.
Oh, over intelligent. It remains the same. Very good, very good. Good try, good try. I am not criticizing you. What about your opinion, Jivika, who joined before 10 minutes only? Yes, Jivika?
Sir, can you ask the question again, sir?
Yes, I am asking again. The question is, if you are heating a liquid whether its density will increase or decrease.
Decrease,
Oh, it will decrease.
I think.
Oh, you think. Okay, okay. It's like KBC when we'll do phone a friend, no? Like that sheet one, I think. Okay, fine. So, you can feel this thing in the real life also. If you ever go to kitchen and your mom is making puri, rarely, but if she is making, then what will she'll do? First she'll pour oil in the kadai. I don't know what you call it in Tamil. Kadai only. Vanai. Okay, too much local Tamil, I think. I don't know. Whatever. So you took a kadai. In that kadai you add 1 liter of, not 1 liter, but they will add some good amount of oil because they want to fry puri, isn't it? Or vada, something you can imagine. So when you put oil in that, and when she ons the stove, and when she starts frying that vada or oil or whatever you want to fry, then you will see that the oil has become like water, very thin. And the same oil, when it is once again cooling down, it will become thick, sticky. If you have not felt it, go and ask your mom to make puri today itself, or tomorrow at least. Already made today. Oh, she will not make. Okay. So go and eat in the nearby shop and stand in front of the place where they are making and ask them to pour the oil on your hand. Then you will but understand that oil will be thin. Are you able to feel it? Can you I mean relate what I am trying to tell? It happens. If not, then go and see in the kitchen, it will happen. That oil, when it is heated, it becomes thinner, and the same oil when it is cold, it becomes thicker. Okay, why it happens, what happens, and all these things we will discuss now. Okay, the heading is variation of density with temperature, right? In liquids, obviously. I should mention here what we are talking is in liquids. Shall I? Okay. Just now you have seen V dash is equal to V into 1 plus gamma delta T. Remember? Today is full day is with alpha beta gamma only. So V dash is equal to V into 1 plus gamma delta T. Very good. We know that density is equal to what by what? Mass by volume. So what will be volume? Very good. What kind of math you are learning? Mass by density, isn't it? So V dash will become equal to M by rho dash. This will become equal to M by rho. Mass remains same. Into 1 plus gamma delta T. Do you agree? It is not like you are having 1 liter of oil. If you heat it, will become 2 liter of oil. I mean, I am talking about the mass. Volume may change, mass will not change. Remember that. Okay, coming back. Mass gets cancelled, and you get the value of rho dash, or rho dash I am writing and making rho to go there. Rho divided by 1 plus gamma delta T. Do you agree? So rho dash will become equal to rho into 1 plus gamma delta T inverse. Can I say like this? Can I say like this? Now, this became a linear binomial expansion, 1 plus x power n, where x is much smaller than 1. This became 1 plus x power n binomial expression, isn't it? Where x, since gamma is a very small value, this x is much less than 1. In that case, what is the expansion value? 1 plus nx, remember? The expansion of this term is 1 plus nx. So rho dash will become equal to rho into 1 minus will come here minus gamma delta T. Are you understanding? Now you can see very clearly that density rho dash will become rho into 1 minus something. It is small value only. So it will make it like 0.9 times of rho. Density reduced. Are you getting a point? Because what is rho? Rho is density. Rho dash is the changed density, increased density, or changed density I should say, not decreasing only obviously, and rho is the original density. So when you heat a liquid, because of heating, what happens to its density? It reduces, because this number will be definitely less than 1. Can you not feel it? If it is going to be less than 1, then rho dash will become equal to rho into 0.9 or something, which is lesser than 1. So the density of the liquid reduces when its temperature is increased. If understood, please copy it fast. Shivaranjani, Niranjan and Nikhil, please on your videos always. Okay, Shivaranjani. Why you are offing video, man? Already I gave time for drinking coffee, no? Once again you want to drink water, milk, where you went?
No, sir.
Went to eat dinner?
My sister was just talking in, so I just thought of.
Okay, don't hesitate for anything, please. Copy this first. Have you copied it?
Yes, sir.
All of you, can I erase the board? Fast, 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 fast.
Yes, sir.
7 minutes, sir.
Okay. So Jivika came for checking whether the class is happening or not. Came 10 minutes and dropped. Okay, good. Half an hour more remaining. What Nikas? At least you're not sleeping in this class, man. You should appreciate yourself. If it is a regular class now, you sleep, right? Now, because of the climate, light and everything, your eyes are open at least. Be happy. Improvement only. Shall I proceed?
So now,
Yes, sir.
I hope everybody has copied fast, fast. 1 more minute. 30 seconds more, fast. I hope you are done. Not done also. Now copy from the video. Fine. I'll proceed further. Now what we are going to see, okay, I'll talk here itself before I go to that point. We understood that whenever the temperature of the liquid is increased, its density starts to decrease. Understood that? So, if I draw a graph between density and temperature, you understand that when temperature is increasing, density starts to reduce. Okay. What about volume? What will happen to volume? Oh, very good. Volume will decrease. Nasta is expansion, no yaar. Expansion is what? Increase only, right? Density is mass by volume. Density and volume are inversely proportional. So, if the temperature is increasing, then the volume will also increase. Am I right? Just draw a rough graph, not the exact graph. Rough graph I am drawing to make you understand that increase in temperature makes the liquid's density to come down and volume to go up. General behavior of all the liquids. Please pay attention, interesting, important topic for the examination. Niranjan, I hope you have spoken to your mother, father, brother, sister, whoever came to meet you.
Yes, sir. Yes, sir.
Yeah. So, I said generally liquids on giving temperature to them, heating it, its volume is increasing and density is reducing, right? But water, it is different from all this. Water shows a anomalous behavior. Give the heading, important topic. Give the heading as anomalous behavior of water. Expect a question to come in school exam. Theory question for 1 mark or 2 mark. What do you mean by anomalous behavior of water? Okay. See.
sir, this screen is getting blurred constantly, sir.
Okay. Then I'll do one thing. I'll make myself to disappear and only screen to be visible. That is fine.
Okay, sir.
Okay. So I think now it will not be blurring because of me being out of the focus.
Thanks, sir.
Okay. So please pay attention. I am seeing you. Okay. You don't think my video is off, so your video also I am not able to see. I am able to see everybody. Niranjan and Nikhil are having video off. Okay. Tarun, Elil also. Coming back. So liquids will expand, its volume will increase if temperature is increasing. Density will reduce if temperature is increasing. if you see the water, very good. She's scolding her sister. Why are you coming and shouting like this? Okay. Shweta, shall I continue?
Yes, sir.
May I always be muted. Don't worry if somebody is coming also. We are not minding. No problem. We understand. Everybody has members in their family. Okay, coming back. Yes. So if I draw the graph of volume versus temperature for whom? Water, it has shown a very peculiar behavior. You know what? The volume of water started reducing from what to what? From 0 degree to 4 degree. And beyond that, like normal liquids, if temperature was increasing, its volume also started to increase. Are you getting my point? I will repeat this. All the liquids, if the temperature was increasing, its volume was increasing, except one liquid. Which liquid? Water, the most abundant liquid. And that liquid, its volume started to reduce with increasing temperature from only 0 degree to 4 degree, and beyond 4 degree, it once again started to increase. What is the big thing in that? I will tell you what very big thing in that. I will say that today's life is possible because of this reason only. Whole ecosystem exists because of this anomalous behavior of water. I will tell you why. So, if volume is increasing, what will happen to density? Density will have the relation like from 0 to 4, density is increasing, and beyond that it starts decreasing. Generally, if temperature increases, density of liquid decreases. But in the case of water, it increases from where to where? 0 degree to 4 degree. And beyond that, it once again decreases. That graph also I think I should have made. Yes, I have made density. So once again you see the graph, you will realize that from 0 to 4 increases, and beyond 4 once again like normal liquids decreasing. I hope you are understood. What is the meaning of anomalous expansion? Anomalous behavior is that from 0 degree to 4 degree, if there is an increase in temperature, obviously 0 degree to 4 degree increase only, that time the volume of water decreases and density of water increases. Okay. Now I will tell you what happens, how it helps. Imagine, very important thing I am speaking, please pay attention. Imagine there is a lake or a pond. Okay, we are in a tropical country where we have no extreme cold climates. We are seeing Tamil Nadu, especially seeing minimum of 15 degree, 14 degree, 16 degree. That itself is very cold for us. But there are countries in the world which sees temperature of 1 degree, 2 degree, 3 degree, minus 10 degree, minus 15 degree also. Am I right? Go to Alaska, Russia and all, too low temperature. Am I right? Go to the side US, many countries are having very low temperatures. So imagine a country where temperature is negative 5 degrees Celsius. What is negative 5? Freezing point of water. If water becomes frozen, how is aquatic life surviving? Have you ever thought about this? Water is frozen, right? So what?
Sir, it only freezes on the top.
Why, Sivaranjani? That is what is the anomalous expansion of water. I hope you have seen some Facebook videos where somebody is inside the water or making hole and taking out something they are doing. So you know the top, yeah, true, what Sivaranjani told is true, that in the case of cold countries, only the top layer of water becomes frozen. My question is why? Minus 5 degree, right? The whole water should become frozen. If whole water should become frozen, all the fish will die. Am I right? Then how is the aquatic life possible where the temperature goes low? And you know one thing, in cold countries, their main source of food is fish only. Because where temperature goes minus 5, minus 6, we don't have much existence of wildlife, neither we have existence of vegetation or not even other animals. So they are depending mainly on fish for their food. And if suppose anomalous expansion would have not been there, then the fish also will not be there for them. Now once again the question comes back, why this happens? To understand this, I have just a small videos there. I hope everybody is able to see who is in the online also. Please pay attention. So there is a small lake where there are fishes, right? And if you see, the temperature is 16 degree now, a good temperature where we go Ooty and all to visit. 16 degree and all is a pleasant temperature, isn't it? But slowly temperature is reducing. See, it became 10 degree now. When temperature start to reduce, what will happen? Water near the surface loses the energy to the atmosphere. That's why it is becoming. See, calorimetry principle takes place. So now see the main part. If the temperature is reducing, what happens? Temperature reduces will make the density to become increase, isn't it? And if density is increasing, then what will happen? It will become denser, it will fall down, and the lower part of the water, which is warmer, will come up. Are you getting my point? Once again, above part it will come down, becoming cold, and then warmer water will go up. This process keeps on repeating. But see what happened. If you see the diagram what I have done now, at 0 degree, the top layer got frozen, and it stopped the further contact of the environment with the bottom layer of the liquid. So in cold countries, the temperature of the water below this ice will be 4 degree only. Yeah, 0 to 4 you can say, kind of. 1, 2, 3, 4 it will be. And top layer again alone will be frozen. I will repeat what happens. If you want, we can explain from here also. If you see, temperature is falling in the cold countries. When temperature is falling, density keeps on rising. At one point, it becomes maximum density. Water came down. After that, further reducing, that is, temperature became 3 degree, 2 degree, density starts to reduce. If density is less, it will remain above, it will not come down. Are you getting? The colder water will not go down itself, it will remain in top layer only. Those who are confused, I am repeating it for them once again. Pay attention and listen. When the temperature of the surrounding is falling, I am taking example 10 degree to 1 degree. 10 degree, 9 degree, 8 degree, 6 degree, it is falling down, density of the water is increasing, right? Since density is increasing, it is coming down. Density is more, it will sink. Am I right? So water is becoming heavier, coming down. The warmer water is light, it will go up. But after, like below 4 degree, when it becomes 3 degree, density suddenly starts to reduce. Since density is reducing, it won't sink inside. So 3 degree water, 2 degree water, 1 degree water will not come down itself, because it is having a lesser density. Are you getting the reason? And so the top layer alone becomes frozen, the bottom layer remains in liquid state, and the fish is able to survive. Yes, Abhinand, please tell me.
The water below the ice can also be 5 or 6 degrees Celsius also.
It may become a little hot also, because the contact has a thing, because of the transfer of heat between the system and surrounding, it may change also.
But if it goes too high, it will go up again because of density.
Obviously. Temperature starts to increasing from, suppose once again coming back from 1 degree, 2 degree, 3 degree, density will increase, it starts sinking inside. Are you getting? So when the outside temperature is becoming normal, it will sink, and once again no problem for fish. So fish life itself is possible because of this anomalous behavior of water. Otherwise, the whole water would have become frozen, and then they would have passed away. Are you getting my point? Is it clear what I have told about the anomalous expansion of water? It's very important for the aquatic life's survival. Okay? If you want to write something from here, you can please write. And that story of fish, you need not to write anything, understand it. But it comes in the examination sometimes. How is the aquatic life supported by the anomalous behavior of water? You should write all this story what I have told to you. Copy this slide. At least that graph of volume and temperature you should write. Draw it in your own way. The previous graph first I will draw. The previous graph was of density. Sorry, volume. This graph have you drawn? This graph is volume versus temperature for the water. Let me know if you have done it. I will go to the next slide then. If you have copied, I'll go to the next slide where you can copy the density versus temperature graph. Shall I? Online people, can I go to the next slide? Okay. Next slide, the graph alone will change. Don't worry about anything else, it will remain the same. I hope you have copied. Loudly. You're asking whether you should remember the values. Not required. Just to make you understand that it has anomalous behavior, these values are being given here. It's not required to remember the values. Okay. So can you put my video on? Yes. So good news for you is that hereafter the class will get over by 9 p.m. Nikas, start laughing. So the class will get over by 9 p.m. because some people have requested that it is becoming too long, 2 hours. They have told too long to me. So what I can do is I cannot give a break 15 minutes in between because you cannot go out anyhow. So what we planned is hereafter all Tuesday, Thursday and Saturday the class will get over same like earlier 9 p.m. but it will start by 7:15 only. Okay, the class starts by 7:15 and ends hereafter by 9 p.m. So when the class goes on in this time 7:15 to 9 p.m. be attentive and be in the class. Between 5 minutes break I am giving, but come on time. Don't make the class to be delayed because of you coming late. Okay, and again I am repeating, if you are coming for the offline section, then carry your water bottles, everything, because it's anyhow it is 1 hour 45 minutes class, so you will get like kind of dehydrated. Okay, so I am winding off here. Today we learned about the alpha, beta, gamma, that is coefficient of linear expansion, areal expansion, volume expansion, and we learned about the anomalous behavior of water. Next class we will learn about the conduction, convection, radiation. Last topic of this chapter. Till then, take care. Bye bye. I am dropping. Take care. Good night.
Thank you, sir. Thank you.
Take care. Take care.